Here's your newly polished and cinematic script for *Waves Discovery*, fully restructured without headings or hashes. It flows as one continuous narrative, perfect for voiceover and visuals. Imagine drifting through the Milky Way, where stars burn like lanterns scattered across a dark ocean and planets spin in silence, unseen and unexplored. Among this cosmic ballet, a mysterious class of planets continues to capture the imagination of astronomers. Exoplanets, worlds that exist beyond our solar system, orbiting distant stars in hidden corners of the galaxy. Until just a few decades ago, the idea of planets beyond our solar system was purely theoretical. Today, we know of thousands, and scientists estimate there may be over 1 trillion exoplanets in our galaxy alone. Think about that. If each exoplanet were the size of a grain of sand, they could not only fill the Grand Canyon but create a new canyon beside it, stretching for miles. And remarkably, around 20% of these may be Earth-like, meaning similar in size, temperature, and perhaps even atmospheric conditions. That's a 1 in 5 chance that somewhere out there, another Earth may exist. But among all these distant worlds, one stands out: Proxima B. Located just 4.2 light-years away, it is the closest potentially habitable exoplanet to Earth. A possible twin in our cosmic neighborhood. And now, with the incredible capabilities of the James Webb Space Telescope, we're getting closer than ever to uncovering its secrets. The James Webb Space Telescope isn't just the next step in astronomical exploration, it's a revolutionary leap. Orbiting 1.5 million kilometers from Earth at the second Lagrange point, Webb is designed to peer into the deepest, darkest corners of space, far beyond what Hubble ever could. Its massive 6.5-meter gold-coated mirror collects more light than any previous telescope, allowing it to detect even the faintest flickers from ancient galaxies, and the chemical fingerprints of distant exoplanets. What makes Webb so powerful is its ability to observe in infrared light. Unlike visible light, infrared can pass through dense clouds of gas and dust, revealing objects otherwise invisible. More importantly, it allows astronomers to analyze planetary atmospheres, identifying water vapor, carbon dioxide, methane, and even signs of oxygen, clues that could suggest the presence of life. Think of it not just as a telescope, but as a space-based laboratory, performing forensic analysis of alien worlds. Every element in an atmosphere leaves behind a unique light signature, and Webb's instruments can decode these signatures with astonishing accuracy. Proxima B orbits the red dwarf star Proxima Centauri, the closest star to our Sun. Because red dwarfs are much cooler and dimmer than stars like ours, their habitable zones, the region where liquid water could exist, are much closer. That means Proxima B is only about 0.05 astronomical units from its star, just a tiny fraction of the distance between Earth and the Sun. And yet, this is exactly where it needs to be to potentially support life. With a mass roughly 1.17 times that of Earth, Proxima B is likely a rocky planet, making it a prime candidate for further study. But its environment is anything but simple. Proxima Centauri is a volatile star that frequently emits powerful solar flares and radiation bursts. These could strip away a planet's atmosphere, unless Proxima B has a strong magnetic field to protect itself, much like Earth does. And then there's the question of time. One day on Proxima B is believed to last 11 Earth days, possibly due to tidal locking. That means one side of the planet always faces the star, trapped in eternal daylight, while the other remains in perpetual darkness. But between these extremes lies the terminator zone, a narrow band where temperatures could be just right. This twilight region, where day and night meet, might harbor the most stable and life-friendly conditions. If humans ever visited Proxima B, we'd find a world both familiar and alien. Imagine sunrises that take days to complete, followed by sunsets that linger for what seems like forever. A day-night cycle so long it could alter our biological rhythms entirely. Would we need to eat differently? Sleep in longer cycles? Our understanding of time itself would be reshaped. But first, we have to ask, does Proxima B even have an atmosphere? Is there water? Could life survive the radiation? These are questions Webb is helping to answer right now. By analyzing how the star's light changes when it passes through the planet's atmosphere. If one exists, scientists can determine its composition. If signs of water vapor, carbon-based molecules, or oxygen are found, it could be the biggest breakthrough in the history of science. Proxima B may be our closest candidate, but it's just one piece of a much larger puzzle. As Webb scans deeper into the galaxy, we're beginning to uncover the diversity of planetary systems. Some with multiple rocky worlds, others with massive gas giants surrounded by moons. Moons, too, could be habitable, and scientists estimate there may be a quadrillion moons in our galaxy alone. That's one followed by 15 zeros, each one potentially a world of its own. Every discovery adds a stroke to the cosmic canvas. Some planets have carbon-rich surfaces. Others may have oceans of lava or skies filled with hydrogen. And in the midst of it all, we're slowly assembling a list of places where life might take hold. At Waves Discovery, we believe this is only the beginning. The search for life beyond Earth is not just a scientific mission, it's a deeply human journey. A journey to understand not just what's out there, but who we are and where we fit in the vast structure of the universe. With every signal decoded by the James Webb Space Telescope, we edge closer to answers. Whether Proxima B becomes the first exoplanet to reveal life's fingerprint, or merely opens the door for others to follow, it has already changed the way we see our cosmic neighborhood. The stars are no longer distant mysteries. They're destinations. And somewhere among them, maybe, just maybe, a second Earth is waiting. Imagine staring into the night sky, knowing that far beyond what the naked eye can see, there's a telescope silently watching the universe unfold. The James Webb Space Telescope isn't just a marvel of engineering, it's our most advanced tool for exploring the unknown. Floating a million miles from Earth, it peers into the cosmic past, decoding secrets hidden in the faint light of distant stars and planets. One of its most intriguing targets is Proxima B, a planet orbiting the red dwarf star Proxima Centauri, our closest stellar neighbor. Located just 4.2 light-years away, Proxima B sits in the habitable zone of its star, an area where conditions might be right for liquid water to exist. This exoplanet has fascinated scientists and space enthusiasts alike because it's not only relatively close by cosmic standards, but it also presents tantalizing similarities to Earth. Could it support life? Could it be Earth's long-lost twin? Proxima B's day lasts much longer than ours, about 11 Earth days. That means if you were standing on its surface, you'd witness sunrises and sunsets that stretch on for days. The impact on daily life would be dramatic. How would sleep cycles work? Would plant life adapt to long periods of light and darkness? These questions are more than just hypothetical. They help shape the parameters of what life could look like elsewhere in the universe. The James Webb Space Telescope is transforming the way we search for answers. Unlike its predecessor, Hubble, which focused mainly on visible and ultraviolet light, Webb uses infrared technology to peer through dust clouds and observe the faintest heat signatures from distant objects. It can detect molecules in the atmospheres of exoplanets, analyze their chemical compositions, and look for key signs of habitability, like oxygen, water vapor, methane, and carbon-based compounds. Then, something extraordinary happened. Scientists monitoring Proxima B detected a signal, an electromagnetic transmission so intricate it defied natural explanation. It wasn't just static or background noise, this was something structured, patterned. For a fleeting moment, speculation surged. Was it a techno-signature, evidence of intelligent life? Or was it an unusual cosmic event, misinterpreted by instruments? The signal never repeated. It faded into silence, leaving behind nothing but questions and a renewed sense of wonder. This mysterious blip reignited conversations around the search for extraterrestrial intelligence. If life does exist out there, would it communicate in ways we could recognize? Could civilizations be using artificial light or other advanced technologies that we're only beginning to detect? Harvard researchers, leveraging the Webb telescope's capabilities, are now trying to find such signs, like artificial lighting on the night sides of exoplanets. Imagine seeing the glow of a distant alien city through a telescope. It's a concept that just a decade ago would have belonged to science fiction. Now, it's a scientific goal. These advancements aren't just about chasing curiosities. They push the boundaries of what we know and what we believe is possible. Every new planet discovered, every atmosphere analyzed, every signal interpreted, these are steps in humanity's journey to understand its place in the cosmos. We're not just studying space. We're asking the deepest questions about existence. Are we alone? What does life look like beyond Earth? And could we ever make contact? The answers won't come all at once. They may not come in our lifetime. But with tools like the James Webb Space Telescope, we've opened a new chapter in exploration. A chapter where we're no longer just observers of the stars. We're participants in a quest that spans galaxies and generations. The cosmos is vast and ever-changing, and we're only just beginning to understand its story. Each discovery is another brushstroke on the canvas of the universe, revealing a bigger picture that connects us all.